Hello students, welcome back to Vast Diversity. Today we're going to be continuing with linear inequalities in one variable. Okay, so let's remember the number line. In the previous lessons we talked about a number line. So here is a number line that we can say that the middle is going to be 0. Then to the right we have the positive real numbers, to the left we have negative real numbers. And we were able to write down some intervals, right? Interval notation. So let's say we have an interval of -1 and 2, right? So essentially, we're going to say that x belongs to -1, which is not included because it's a parenthesis, comma 2 with a square bracket. So that's a square bracket, means that it's included, right? But there is another notation we can use to actually write this down, and we can use inequalities, right? For inequalities, we will say, okay, well, x, let's say greater than -1, right? We're going to say it's greater, right? X is greater than -1. Then we can also say that, well, x is less than or equal to 2, right? X greater, x less than or equal, right? This is the notations. This is less than or equal, then the opposite would be greater or equal. This is less than, oh, this is greater than, and this is an opposite would be less than. Okay. And okay, so how can we write this x? This x can be rewritten as -1 less than x less than or equal to 2, right? That kind of notation implies that we are specifically talking about this interval, right? This interval of numbers and nothing else. Okay, so an example. So if we were to say, let's say we have infinite number, infinite amount of numbers. So we would say, okay, well, example 1 would be, well, let's say we are from 0 to infinity. Okay, so how about this? Let's go ahead and actually do a number line. In a number line, we're going to say, okay, we have a 0, we have a 1, we have 2, and here somewhere we have a positive infinity. Okay, and so what would be our interval here, actually? Our interval would be from 0, right, a parenthesis, to infinity. So it would be this entire interval of the positive real numbers. So, okay, so how can we write the x? X would be greater than 0, but less than infinity, right? Positive infinity. And then similarly, right, we can do for example 2. If we have negative infinity to, let's say, -1, right? And that would be the x interval here. So how would we draw that? We would have, once again, a number line. And here we have 0 in the middle. Here we have -1, -2, -3, etc. And here we have negative infinity. So our interval from negative infinity not including to -1, which is also not included. So it's everything between, right? Everything in between them two. So we can write it down as negative infinity less than x less than -1, right? So the more negative we get, the smaller the number gets, essentially, right? So it's everything to the left, right? We don't have to sometimes label the infinity. We can just imply that it goes on and on and on as far as we label the interval. But that would be the representation on the number line. Now, let's think about the properties. The properties of the inequalities. So the most important property is multiplication problem. Well, let's go through all of them. So let a, b, c, and d be real numbers. And number 1 is a transitive property. So in algebra, this is very common to have a transitive property. So if a is less than b and b is less than c, then that implies that a is less than c. Okay, this is called transitive property. And it exists in a lot of parts of algebra. Same thing goes to equality, right? You can say that a is equal to b is equal to c. That implies that a is also equal to c, right? This is also a transitive property. That's one of the ways of transitive property. Okay, then if we, let's say, add inequalities, right? So we have a is less than b and c is less than d. We can also write it down as a to be less than b and c to be less than d. Then we can directly add them, right, by the sides of the inequality sign. So we would have a plus c less than b plus d. Okay, and then addition for a constant, if we would like to add a constant, we would have to add it to both sides of the inequality, right? Because we can move subtraction and addition just the same way as we would move the addition and subtraction as in equality case, right? So there's no difference. However, for multiplication, it's slightly different because for, let's say, a constant c greater than 0, if a is less than b, we can just directly multiply and the sign stays the same. However, if we decide to multiply by a negative number, right, c less than 0, right, and we're multiplying this inequality a less than b, then the sign would change, right? So the sign would from less than becomes greater than. So a times c going to be greater than b times c. Okay, this is important. This last rule is very, very crucial. And of course, the same thing would apply to equality. So if, let's say, for c greater than 0, a is less than or equal to b, that would be the same thing as a times c less than or equal to b times c. Okay, but for c less than 0, a less than or equal to b, that would become a times c greater or equal to b times c. Okay, that is important. So this is essentially the properties. Let's go ahead and take a look at one more example, right? So example 3. So we would have something of -2 is less than 5, right? So what can we do here? Let's go ahead and multiply by -1, or let's do -2, right? Let's do go ahead and multiply by -2. So if we do -2, we would have, so -2 times -2. Now we have to flip the sign because the overall number here is negative. So we're going to have greater than -2 times 5. And now we can simplify. So -2 times -2, that's 4, is greater than -2 times 10, that's -2 times 5, that's -10, right? So 4 is indeed greater than -10, and we can check it on the number line. Okay, so this is very important when we solving equations, right? So I'll give another example here. So example 4. So let's say we have x plus 7 is less than 4. Right, so here we have just an addition, so we can go ahead and subtract 7 from both sides. So plus 7 minus 7, that's 0, so x plus 0 is just x, less than 4 minus 7, which is -3. Right, we do not change the sign. But if, let's say, we had example 5, we would have -2x plus 7 is less than 4. Then we know -2x is less than -3. So here we have to divide by -2. And division is essentially an inverse of multiplication here. So we would multiply by -1/2, right? So multiplying by -1/2. So it's a negative number. It's less than 0. So we would have 2 and 2 cancel out. So we would just have x is greater than -2 times -1/2. That would become positive 3/2. Okay. Right, so that would be an example for the properties of the inequalities. And we can also be solving the linear inequalities. And one of the ways we can also solve it is graphically. So we'll take a look at a few problems, and then we will see the graphical solution to it. So let's take a look at example 6. So if we have 5x minus 7 is greater than 3x plus 9. Okay, and we want to solve for the x value. So we wrote out the original inequality. Then let's go ahead and first move x to one side and then all of the constants to the other side. The first step is going to be to subtract 3x from both sides. Okay, so on the left side we have 5x minus 3x. That becomes 2x. And we're going to bring down the -7 is greater than, so 3x minus 3x, that's just 0 plus 9. So 0 plus 9, it just becomes 0. I mean, 9. So 0 doesn't affect anything, so addition to 9 is just going to be 9. Okay, all right. So we got rid of the 3x, moved it to that side. Okay, now we know that 2 times x is multiplication, so we're not going to yet divide, but we first going to get rid of the subtraction here. So to get rid of subtraction, we have to add 7 to both sides. Okay, so we're going to have 2x is greater than 9 plus 7, going to be 16. Okay, and now let's go ahead and divide both sides by 2. So 2 and 2 becomes 1. 1 times x is just x. And it's greater than, so 16 divided by 2 will be 8. So our solution is x is greater than 8. Okay, since we didn't have any negative numbers, we didn't have to flip any signs, right? And of course, what we can do, we can graph this solution to this equation if we would like to have the two lines intersect, right? In another way we can do it is we can say, so y1 is equal to 5x minus 7, y2 is equal to 3x plus 9. So essentially, we're looking when this y1 is greater than y2, so we can graph it and we can tell which one is greater. So let's go ahead and do that. So we can find the points on the graph. So for y1, so when x is equal to 0, we are at -7. And when x is equal to 7/5, which is like right about, so let's say this is 1, this is 2, so we are right about right here. So that means our equation somewhere here, right? This is y1. And then for y2, we have 3x plus 9. So when x is equal to 0, we are equal to 9. Right, let's say this is 9. And when we are looking at, let's see, when we are looking at another point, which would be -3, so 1, 2, 3, -3, we would have a 0, and we would have this solution. Let's see. Right, so we know if we would extend this line, we would intersect at a point, and that point would actually be 8. So we know that past that point, y1 is indeed going to be greater than y2. Okay, so that's how we can think of it. And now let's take a look at another problem. Another problem specifically, let's take a look at one of the problems from the book. So I'll give it as an example 7. So example 7 is we want to have 1 minus 3/2x is greater or equal to x minus 4. So in this case, well, we can go ahead and solve this equation. So let's multiply this equation by 2. Right, since 2 is positive, we do not change the inequality, but we not change the sign of the inequality, but we're just going to have 2 minus 3x greater or equal to 2x minus 8. Okay, now let's go ahead and move everything to the left. So we're going to first move the 2x. So we will have 2, so -3x minus 2x is going to be minus 5x is greater than or equal to, so this is canceled out, -8. Then we're going to go ahead and subtract the 2 from both sides. So we'll have -5x is greater or equal to -8 minus 2, that's -10. And the next step is for us to divide, right? And we're going to divide by -5. So essentially we are multiplying by -1/5. So we do have to change the sign of this inequality. So we're going to have that x is less than or equal to, so -10 divided by -5, that's 2. Okay, so we had to flip the sign. And here would be an example of how the graphical solution would look like for this problem. So here we have that using the graphical utilities, and one of the utilities you can use in general and for any mathematics or any math class, you can go to desmos.com and actually graph all of the inequalities and all of the functions that you're dealing with. So using the graphing calculators, right? y1 and y2 are given here, and we can take a look at this. So we know the intersections, right? So when x is equal to 0, we are at -4. This is -4. When x is equal to 4, this is 4, so we got 2 points. Then here, when x is equal to 0, y is equal to 1. And then when x is equal to, let's see, so that is 2/3. Right, this is 2/3 right here, 2/3. Then that's equal to 0. Okay, so we graphed 2 equations and we found a solution. Right, the solution here is right here. So we know that the left equation is greater. And by greater, graphically, the red equation is 1 minus 3 over 2x. By greater, it means it has to be on top. It has to be higher than the other equation. So perfect, yes. So all of this area right here, it's indeed higher than the other equation, right? Everything right here is higher. So red line is higher than the blue line. So that's why past the 2, so less than or equal to 2, we do have the solution to the inequality, right? That would be an example. Now we can also deal with the absolute value. So let's take a look at absolute value. For absolute value is, we did cover a little bit and touched on it, that it has an interesting properties of switching the sign, but why is it important is specifically for the inequalities. So let x be the variable on algebraic expressions and let a be a real number such that a is greater than 0. So the solution to absolute value of x less than a are all values that lie between negative a and a. So essentially, that's what this means, right? It means that if the absolute value of x less than a, this is what it means, right? We're between negative a and a. And the solution for absolute value of x greater than a are all of the values that are less than negative a or greater than a. And so that is the following. So it's x is less than negative a or greater than a, right? And this rules can also be applied to replace all of the signs with greater or equal or less than, right? So let's actually get to look at the example. So absolute value. Right, this is absolute value, and we write it as absolute value of x or any number. And the property of it is going to be that it's making something negative and it's making something positive. So you can review one of the previous lessons. But essentially, absolute value of x is equal to, so x when x is greater than 0, negative x when x is less than 0. Okay, that's a basic definition of it. But here we could shift it to a value, but based on the problem and on the setup. But let's take a look at an actual example. So I'm going to call it example 2.1. So we have absolute value of x minus 5 is less than 2. Okay, so what does that mean? That means we have two solutions, right? We are dealing with x minus 5 is going to be either less than 2 or greater than negative 2, right? And so, well, the rules of inequality still apply. We have just double inequality. We can just add to each side a 5 to have a balance. So we're going to have negative 2 plus 5, that's 3, less than x, less than 2 plus 5, that's 7. Right, okay. Or we can also write it as x belongs to 3, 7. Right, another notation for it. Okay, so we found a solution. Okay, now how about the following example? So example 2.2. So we're going to have absolute value of x plus 3 is greater or equal to 7. Now we have greater or equal. So now we can have two cases. So case 1 is when x plus 3 is less than or equal to negative 7. Or case 2, when we're going to have that x plus 3 is greater or equal to 7. Right, so here is an important note. We have changed the sign. When we flipped it to negative, we changed the sign of the inequalities to the opposite. So we had greater or equal, now it became less than or equal. Okay, so let's solve the left inequality, the case number 1. So we're going to subtract 3 from both sides. And we're going to have x is less than or equal to, so negative 7 minus 3, that's negative 10. And then in the other case, we're going to once again subtract 3 from both sides. But this time we're going to have that x is greater or equal to 7 minus 3, that is 4. Okay, and a number line, right, that solution to this inequality would be slightly different than the rest of them. We would have to use the notation which unites the interval, right? So if we have 0, let's say 1, 2, 3, 4, right? And actually let's do it a little bit. 1, 2, 4, and then negative 1, negative 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Negative 10. Okay, so our solutions here are all the way to the right, and all the way to the left, right? And that's in this case that is included. Okay, perfect, both sides. But how can we write it out as an interval notation? So we'll say that x belongs to the set from negative infinity to negative 10, and then we're going to union it. So we're going to put a u, right, which is a union. We covered that in a few lessons back, and that's going to be from, since it's included, so we're going to be from 4 to positive. Right. Perfect. And that would give us the solution to this example. Okay, so let's take a look at one of the applicational example for the inequalities and equalities. You probably have seen similar examples or have encountered in previous classes, but let's take a look at this one. So you are choosing between two different car sharing plans. Plan A has a membership fee of $12 per month plus $9.25 per hour. Plan B does not have a membership fee and charges $10.75 per hour. How many hours must you use the car in 1 month for Plan B to cost more than Plan A? Right, so let's make some equations, right? So we want to make sure, well, Plan B greater than Plan A, right? This is our main question. So let's say that, you know, our variable here is going to be h, which stands for hours. Variable h. So let's first find monthly cost for Plan A. So monthly cost for Plan A, what would that be? So we have plan membership has $12. So we're going to say that that's equal to going to be $12 plus 9.25 per hour. So it's going to be 9.25 times the hour, right? Our variable h. So it depends how many hours we have. That's how much money we'll add on. And then 2, once again, it's going to be monthly cost for Plan B. Is going to be, so here we just straight up have a charge of 10.75 per hour. So it's going to be $10.75 times hour. Okay, and we're looking for Plan B to be greater than Plan A. So we're going to have 10.75 times hour is greater than 12 plus 9.25 times hour. Okay, so let's go ahead and solve this problem. So what are we going to do? So I'm going to go ahead and subtract 9.25 times hour from both sides. So we're going to have 10.75 minus 9.25, that is 1.5 times hour, is greater than 12. And so now we're going to go ahead and divide by 1.5. In this case, that is a positive number, so we do not change the sign of the inequality. So we're going to have that hours are greater than, so 12 divided by 1.5, that's going to be 8. Right, so Plan B costs more when you use car for more than 8 hours in 1 month. Okay, perfect. And that would be essentially the solution. Right, so if we use more than 8 hours, the Plan B is going to be more expensive than Plan A. Okay, perfect. Now, let's go ahead and take a look at another kind of inequalities. Right, so besides having a regular inequalities, we can also have a polynomial inequality. So in this case, here we had linear inequalities, right? Polynomial inequalities. So what have we covered so far? We covered quadratic equations. And quadratic equations are in the second power. So let's take a look at an example such that ax squared plus bx plus c is less than 0. Right, this is a polynomial inequality. And of course, it's indeed going to be changing signs as we are going through the roots of the equation. So as we go through zeros of the inequality, right, of the specifically equality. So in this case, right, let's take a look at more of a concrete example. So example of 3.1, and that example is going to be x squared minus 2x minus 3 is less than 0. Right, so the first step that we're going to take is, well, we're going to say x squared minus 2x minus 3 is equal to 0 because we want to solve it. Right, so how can we solve it? We can use the cross method. So something plus something is -2, something times something is -3. So the only options we got is 1 and -3. So we can factor it out. So we're going to have x plus 1 times x minus 3 is equal to 0. So that means either x plus 1 is equal to 0 or x minus 3 is equal to 0. But in this case, you know, we need both. So we're going to have that x is equal to -1 and x is equal to 3. Right, we have two solutions. But here, that means we have 3 intervals, right? Even though we have 2 solutions, we have 3 intervals. We have an interval from -infinity to -1, not included because we're not including this because it's going to be 0 at those points. Then we have an interval from -1 to 3, and from 3 to positive infinity. Okay, so here we have to think of when the equation is actually less than 0. And there is only one, in this case, there's going to be only one interval. And here we can test it, right? We would have to test the interval by plugging in a point directly, right? So I would have, let me give you a drawing of what would be happening on the number line specifically. So for a number line, we have the following, right? We found the zeros of the equation. So the zeros of the equation are -1, which we found, and 3, right here, which are not included. So here we're looking at the part when the values are below the x-axis, right? Below the x-axis. So here this is a parabola, and we know that this is the solution. So the actual parabola would look something like this. It would be like this, just scale up like this, right? And it would travel upwards. So here we have that this part, right, is indeed less than 0, right? Because everything else would be above the x-axis. So that would mean that it is positive. Okay, so here this is one of the ways we can do it graphically, but sometimes graphically is not convenient, right? So we would have to do it mathematically, algebraically first, and then we would have to draw a conclusion. Okay, so what would be the steps that we can actually take in order to determine what interval do we need? Here, let's go ahead and outline them. So the first step is going to be to determine on which values the polynomial are entirely negative or positive, right? We would say find all real zeros, right? We were only interested in real zeros, no complex zeros, and arrange the zeros in increasing order. So the zeros are the key numbers of the inequality, right? And the reason why we would want to in increasing order is to be able to think about the number line at the same time. So we would use these key numbers of the inequality to determine the intervals. After that, we would choose the representative x values in each test to evaluate if the interval is positive or negative, and if it satisfies the inequality, and then we would choose the signs. Okay, perfect. So once again, let's think about, let's take a look at another example. So another example would be example 3.2, right? And we're going to say, well, x squared minus x minus 6 is less than 0. Okay, so once again, step 1, x squared minus x minus 6 is equal to 0. So we want to factor out. So we have something times something, it's something plus something is -1, something times something is going to be -6. So the only thing we can have is 2 and -3. So we're going to have x plus 2 times x minus 3 is equal to 0. So we're going to have x plus 2 to be 0, or x minus 3 to be 0. So then x is equal to -2, and x is equal to +3. Once again, right, everything to the left of -2, we're going to have an interval from -infinity to -2, not included because we have less than, not the equality here. Then the second interval will be between them two, so it's -2 and 3, and the last interval would be 3 to +infinity. And if we check, let's say we plug in 0. If we plug in 0, right, x is equal to 0, we're going to have 0 squared minus 0 minus 6, which is going to be -6, and that is less than 0. So this interval would be the solution to our inequality, right, in order for us to satisfy the inequality. Okay, perfect. Right, so that would be it for this lesson, and next time we're going to be starting to talk about linear equations in 2 variables and functions. Thank you.